said before, many other different areas within that organization. So I think there is a lot more positive views on how to apply artificial intelligence. I think where we need to move the needle is to start to focus. I think that's a key message I would have for the C-level organizations is let's focus on one of your big challenges and let's help with that big challenge. Let's not try and bite off too much and prove that this does work and we are able to accelerate the work that you're doing, improve the output of what you're doing, improve the success rate of what you're doing. And that will then show that a much wider scaled program of work across your organization will be required to be successful.
When you say big challenge, I mean, if it takes 12 years to develop a drug, then that could be a decade worth of, you don't mean that big a challenge. What do you mean by, give me an example of a big challenge that would be, bite-sizable?
Yeah, so I think if we can take hundreds of thousands of images and be able to identify those images for a specific disease area that they are targeting a particular drug, that they want to have more confidence that drug is having an impact in those areas, and we're able to gain further insight from those images, or we're able to identify that this particular cohort is common to a particular set of cohorts within those images, then those are the kind of programs we're looking for. Yes, very specific user cases, but they're ones that we want to show the power of the GPU, the power of our platform. So that's what we're trying to get to, is where we can be quite specific, but we also are dealing with large amounts of data.
Wonderful. I mean, that's all my questions. I think, Carolyn or Reshmi, any sort of things. I mean, what I will tell you as an XPR person is, that probably felt like it went really fast in your head, and you probably only said half the things you need to send. In reality, you've said about twice as much as we need, to be able to write an article. It's like just a human thing where and it's anything you can learn over time to be really succinct. I think you did great. I mean, you have a couple of points where you're trying to, always think of it as, I've got one or two things to say. I've got three things to say. Even if you don't say 1, 2, 3, just you've got 3 sentences really to be able to give an answer before people lose attention, basically. But I thought that was pretty good. But Reshmi, Carolyn, what other question might you have asked? But I mean, this is just for a fairly straightforward blog post. That I would make it around the insights. I would start with the last question and make that the start, and then just go into some of the more detailed areas and then give an example or two. The only thing, the weakest bit was the example, I thought.
Maybe just a question to make to add some numbers to this. So, Craig, you mentioned when you started talking about the challenges, you said there's the high cost of drug development, the length of time it takes, and the number of failures. The only thing that you actually put a tangible number to among those 3 was the length of time it takes, 12 years. Do we have an average cost of drug development as well?
That's $5 billion.
$5 billion. And what is the failure rate? Is there a percentage there?
Usually above 85%.
Okay, I think those are good statistics to include, right?
Yeah.
Yeah, fantastic. Yeah, perfect.
So I would say it's usually about 93%, but I would just say above 85% just to cover the better pharmaceuticals. That would argue that they're slightly better than 93. But when you average it out.
So is there any way we can already quantify how with GPUs we could reduce that? So in other words, we could reduce the time it takes from 12 years to X. Is it years, months? Reducing the cost and increasing the failure or reducing the failure rate? Is there something where is there some tangible example? Because that would be amazing, right?
Yeah, that would be amazing. But you're going into the cancer question again. I think the quantum